Everyone was waiting for Google to drop Gemini 3.5 Pro, a massive, universally intelligent powerhouse. Instead, in July 2026, Google delayed that flagship and divided their focus across three specialized, lower-tier models under the Flash banner. When you hand an AI agent a complex, multi-step workflow today, things usually break down. The agent drops the thread of what it was supposed to do, gets trapped in execution loops, or burns through so much compute that the process becomes too expensive to justify. We've reached a point where the main hurdle to building reliable AI agents is no longer a lack of raw intelligence. We have smart models. What we lack is mechanical efficiency and sustainable unit economics. By releasing these three specialized Flash models, Google is stepping back from the race for a single smarter brain. They've built a surgical toolkit engineered specifically to fix the mechanical plumbing of autonomous execution. The heaviest lifter in this new toolkit is Gemini 3.6 Flash. Interestingly, it doesn't try to be smarter than its predecessor. It maintains the exact same intelligence score of 50. Its mission is solving reliability and memory drift in long workflows. To do this, Google engineered thought signatures. Instead of recalculating its original intent, it anchors its intermediate logic directly into the conversation history. Holding the logic steady allows the model to safely execute multi-week enterprise processes, preventing expensive execution loops. Because the AI isn't wasting processing power retracing its own steps, it requires far less compute. In practice, 3.6 Flash consumes 17% fewer output tokens to complete the exact same tasks. That efficiency translates directly to the balance sheet. The model processes at 304 tokens per second, and the output cost is now $7.50 per million tokens. Solving context loss mechanically, rather than trying to outthink the problem, turns fragile multi-step logic into a structurally sound foundation for enterprise agents. But not every task requires deep, complex logic. If you deploy a heavy reasoning model to perform millions of simple data sorting actions, the API costs will quickly ruin your budget. That's where Gemini 3.5 Flash-Lite comes in. It's a surgical solution built specifically for high-throughput, low-latency workflows, tearing through data at 350 tokens per second. The key feature here is configurable thinking levels. Developers can explicitly dial down the reasoning effort for basic tasks, stopping the model from overthinking simple commands and stripping away unnecessary token bloat. Stripping away that friction drops the unit economics through the floor. Processing costs plummet to just 30 cents per million input tokens and $2.50 for output. By granting developers granular control over how much brain power they actually pay for, Flash-Lite takes massive, repetitive sensory tasks and finally makes them economically viable to hand over to an AI. The third major bottleneck in autonomous systems is the search space problem. Finding deep vulnerabilities in sprawling enterprise codebases requires exploring millions of execution paths, a task too vast and expensive for a single model to scan efficiently. Google's answer is Gemini 3.5 Flash-Cyber. It's a highly specialized and restricted model, fine-tuned entirely for finding and patching code vulnerabilities. It operates inside Google's CodeMender system as a multi-agent swarm. Instead of making one expensive call to a giant model, the system dispatches multiple cheap agents to scan different code paths in parallel, casting a much wider net. But this capability comes with a serious operational danger. The model is inherently dual use. A system intelligent enough to locate complex vulnerabilities is also capable of generating functional exploits that bypass standard security protections. Because of this threat, Google has locked Flash-Cyber entirely behind a gated pilot program for vetted partners and governments. The future of AI deployment will be heavily tiered and restricted by capability. When you step back and look at the macro industry view, it's clear that the era of relying on one massive, expensive monolithic AI to execute every single digital task is officially ending. We are moving into a new operational reality. Autonomous execution requires a collaborative, decentralized network of specialized nodes, all designed to operate as a quiet, invisible ecosystem. The division of labor across this new stack is precise. Flash-Lite processes the high-volume sensory data, 3.6 Flash orchestrates complex multi-step logic, and Flash-Cyber secures the perimeter. When you combine unbreakable architectural constraints with plummeting token costs, you finally get software agents that can afford to run continuously and reliably in the background of enterprise operations. Prioritizing unit economics and mechanical reliability embeds this model family as the invisible, concrete infrastructure of the next generation of software.